Hey class, we're going to do lesson 2.4 in this video, and we're going to learn how to take the derivatives of all 6 trig functions. We already did sine and cosine in lesson 2.3, and we'll use the product rule and quotient rule to help us see how we can find the derivatives of the other trig functions. Now, we learned that the derivative of sine is equal to the cosine of x, and the derivative of cosine is equal to the opposite of sine x. We talked about that in the last lesson. Let's go ahead and find the derivative of cotangent of x using that cotangent is equal to cosine of x over sine of x. So that's the quotient of 2 functions that we know the derivative of. So quotient rule. Low d high minus high d low all over the square of what's below. Got to say that out loud till you know it good. All right, so low d high, derivative of cosine is the opposite of sine, minus high d low, derivative of sine is cosine, all over the square of what's below. So the square of sine of x. All right. So this gives me the opposite of sine squared of x minus cosine squared of x. So I could just go ahead and factor out that negative. All right, I'm hoping you remember some trig identities. Sine squared of x plus cosine squared of x is 1. So this is, oh, I forgot my bottom. Of my derivative. Okay, so sine squared of x plus cosine squared of x is 1. I have the opposite of that over sine squared. All right, and the reciprocal of sine is cosecant. So this is equal to the opposite of cosecant squared x. So we can write that in up here. The derivative of cotangent is the opposite of cosecant squared x. We could do the same thing basically for tangent of x, starting with sine x over cosine x. We would get that its derivative is secant squared of x. All right, and let's go ahead and find the derivative of secant of x. So got all these colors, might as well use them, right? All right, so if y is equal to secant of x, well, secant of x is 1 over cosine, right? So I can use the quotient rule again. So y prime equals, say it, low d high minus high d low all over the square of what's below. So low d high, the derivative of 1 is 0. So that's just going to be 0 minus high, so 1. D low, derivative of cosine is the opposite of sine of x, all over the square of what's below. So all over cosine squared. All right, so cosine x times 0, this is just 0. And then I have plus sine x over cosine squared of x. The way this is usually written is that we separate that out, and we have 1 over cosine of x times sine of x over cosine of x. Just separating that into a product of 2 fractions, which would be equal to that. All right, well, 1 over cosine is secant, sine over cosine is tangent, and it is usually written as secant x times tangent x. So the derivative of secant is secant times tangent. All right, so we can fill that in up here. Maybe we'll go back to that other color. Secant x times tangent x. And I'm going to go ahead and tell you that the derivative of cosecant is minus cosecant x cotangent x. Now it's worth taking a minute and looking at these 6 derivatives. Notice that all the trig functions that start with a c, cosine, cotangent, cosecant, their derivatives are negative, negative sine, negative cosecant, cotangent. And the trig functions that don't start with a c, like sine, tangent, and secant, their trig functions do not have a negative. Their derivatives do not have a negative in front of them. Sine and cosine, kind of have our little pals there. They're kind of each other's derivative. Notice derivative of tangent and cotangent. One is secant squared, the other is cosecant squared. I don't know if you remember co-functions, but secant and cosecant are co-functions. Tangent and cotangent are co-functions. So if you know the derivative of tangent, think about, well, the derivative of its co-function would be the co-function of its derivative, just with a negative in front. Same thing here, secant and cosecant are co-functions. Secant and cosecant are co-functions, tangent and cotangent are co-functions. So it helps in terms of memorizing these because, yeah, you do need to memorize. You need to know these 6 derivatives. All right, so just let's maybe do a little example here. If you had y equals, say, sine x times cosine x, if you wanted to find that derivative, okay, we would need to use the product rule that we learned yesterday. And the product rule says that you leave your first function, so sine, derivative of cosine is the opposite of sine. So I left the sine, took the derivative of cosine, plus, now I'm going to take the derivative of the sine, take the derivative of sine x here, which is cosine of x, and then leave the cosine of x. So this is equal to minus sine squared x plus cosine squared x. All right, that is not equal to 1, okay? If I had just sine squared plus cosine squared, that is equal to 1, but I don't. I have a minus out here. So I think we'll just leave it like that. Let's maybe do one other example. Let's say you had g of x is equal to tangent of x times 3x plus 5, okay? If I'm going to take its derivative, I'm using the product rule again. So I'm going to first of all leave the first function, just tangent x. Derivative of 3x plus 5 is just 3. Plus, now I'm going to do the derivative of tangent, which is secant squared of x. All right, and then I leave the 3x plus 5. And it's not particularly pretty, and I can't really do much simplification, but hey, that is the derivative. That's my answer. Okay, let's go ahead and do a few other examples here. Find the equation of the tangent line to y equals 2 sine x plus cosine x at 0, 1. All right, so derivatives give us slopes of tangent lines. So that's the first thing I'm going to have to do is find the derivative of y. All right. Derivative of 2 sine x is going to just be 2 cosine x plus the derivative of cosine x is the opposite of sine of x. So 2 cosine x minus sine x is my derivative. Now, I want the slope of the tangent line, the equation of the tangent line at the point 0, 1. Okay, folks, sorry about that. Let's go back to sharing my screen so you can see what's going on here. Give me just a second. Sorry about this, guys. Okay. All right, so we're finding the equation of the tangent line. All right, so in order to find the slope of the tangent line, I will plug the x value, which I'm getting from right here. Okay, I will plug that into my equation. So that's 2 times the cosine of 0 minus the sine of 0. All right, cosine of 0 is 1, sine of 0 is 0. So it looks like my slope is 2. All right, so I have the point 0, 1. I was told that again right here. I was given both the x and y coordinate. And from here, I have the slope. So I just need to write the equation. Now, in calculus, it is really best, put this in another color, to use this, the point slope form for the equation of a line. It's quickest, it's easiest. Some of you are used to using the y equals mx plus b form as a way to write an equation of a line. You can, it's not wrong. It just takes a little more work. And the thing is, you don't have to simplify your equation. So look how easy this is. I just do, okay, so y minus my y coordinate, which is 1. My slope is 2, x minus my x coordinate. Y minus 1 equals 2x. And if I want to, it's really easy to bring that 1 over. But I don't even actually have to, but it's really easy to. And so there's really very little calculation that has to be done, whereas if I use this equation up here, there's more calculation and there's more of a chance for an error. So I strongly, strongly, strongly recommend that in writing equations of tangent lines that you use this form, point slope form for that. Okay, let's just find a couple derivatives here. All right, so f prime of x. Notice I have the product of two functions. Well, I shouldn't call that f of x. It's just two functions. Let's say g of x and h of x being multiplied. So I'm going to be using my product rule. Okay, so if I leave the first function is x squared plus 1, leave it alone. The second function is sine x, its derivative is cosine x, plus, now I'm going to take the derivative of the x squared plus 1, which is 2x, and then I leave the sine x. Again, not particularly pretty, but hey, it is my derivative, and that's it. There's really not much more I can do with that. All right, this derivative of g of x equaling cotangent x over x, it is the quotient of two functions, so I'm going to be using the quotient rule. Say it, low d high minus high d low, all over the square of what's below. All right, I can almost hear you. Okay, so low is x. D high, derivative of cotangent is minus cosecant squared of x. And low d high minus high, and the derivative of x is just 1, all over the square of what's below, so all over x squared. Not a whole lot I can do with this. I might write it as minus x cosecant squared x minus cotangent x, all over x squared. So there you go. All right, let's find the equation of the tangent line to the curve x secant x at the point pi over 3 and 2/3 pi. All right, so I've been given the point where I want the tangent line, and so I need to find the derivative of my function in order to find the slope of the tangent line. So x is my first function, leave it alone. Derivative of secant is secant x tangent x, plus, now the derivative of x, and then leave my second function, which is secant x. So that's just x secant x tangent x plus secant x. All right, I need to plug in my x coordinate in order to find the slope at that point. So f prime at pi over 3 is pi over 3 times the secant of pi over 3 times the tangent of pi over 3 plus the secant of pi over 3. All right, I might make a little circle up here, just kind of reminding you a little bit about your trig circle. If you don't know your trig circle, practice it, guys. You need to know your trig circle. All right, pi over 3 is up here. The coordinates are 1/2 root 3 over 2. That is your cosine and sine. Cosine comes first in the ordered pair and then sine. So this is pi over 3. The secant of pi over 3, secant, remember, is the reciprocal of cosine. Cosine is 1/2, so that would be 2. The tangent is sine over cosine. So if I do root 3 over 2 over 1/2, that'd just be root 3. And then secant of pi over 3 is 2. Not pretty, but that is my derivative. That is my slope. So my ordered pair is pi over 3, 2/3 pi, and my slope is this thing, the whole thing. So that would be 2/3 pi root 3 plus 2. All right, remember we're putting it in this form, and this is definitely one where you would want to just use this equation. It's going to be a lot simpler than trying to do the y equals mx plus b thing. Y minus y1, my y1 is the 2/3 pi equals the slope right here. That's the slope. So 2/3 pi root 3 plus 2. All of that, I should have parentheses around that because that's all getting multiplied by x minus my x1 value, which is the pi over 3. There we go. And you can leave it like that. Glory be, right? You don't want to be simplifying that. All right, so that's the equation of the tangent line to the curve at that point. All right, so now we're going to take the derivative of cosine of x over 2 plus sine x and find for what values of x does the graph have a horizontal tangent. All right, remember horizontal tangent, if we got a function here, the horizontal tangent is where that function changes from increasing to decreasing. Not sure you can see that. Horizontal tangent means the slope is 0. So we're going to want to find the derivative and then set it equal to 0. All right, so let's find the derivative. Low d high minus high d low all over the square of but what's below. Low, 2 plus sine x. Put parentheses around it. D high, derivative of sine is negative, of cosine is negative sine. Low d high minus high is cosine x, d low. All right, the derivative of 2 plus sine x would just, whoa, I hit something there, didn't I? Okay, would just be cosine of x all over the square of what's below, 2 plus sine x quantity squared. All right, so we need to do a little simplifying here. I'm going to distribute here. I'm going to distribute this out. So I'll have minus 2 sine x minus sine squared of x. And then this gives me minus cosine squared of x. Okay, that's all over 2 plus sine of x squared. Okay. All right, so focusing on this here. All right, if I factor out a -1, I have sine squared plus cosine squared. That's one of the coolest trig identities there is. So if I factor out the -1, I have minus sine squared plus cosine squared of x all over the 2 plus sine of x squared. Okay, and that sine squared plus cosine squared gets replaced with 1. So I have -2 sine x minus 1 all over 2 plus sine of x quantity squared. So that's my derivative, and I want to set it equal to 0. So I'm going to set it equal to 0. Now, the only way that a fraction, when you divide, in other words, is equal to 0 is if your numerator is equal to 0. So all I really care about is this numerator being 0. So this would mean that 0 must equal -2 sine x minus 1. Not sure that's... Okay, so I have, if I bring the 1 over, 1 equals -2 sine x, divide by the -2, I have sine x equals -1/2. All right, if we think about the trig circle, sine is -1/2 here and here, where basically the y value is a -1/2. That's at 7/6 pi and at 11/6 pi. Now, this didn't say that we should only find values within a certain range, so that means all real values. And I hope you guys remember some of this from doing trig equations last year. If I start with 7/6 pi, I can add or subtract 2 pi n times. Okay, because if I'm here at 7/6 pi, I could go around a full rotation and land back there. However many times I want, I could keep doing a full rotation, which is 2 pi. Or I could subtract 2 pi. I could go backwards a full rotation from there and I'd still land there. And of course, same thing with 11/6 pi. So yeah, all of this is my answer. All right, it's good to review, but to be honest, you don't have to do a whole lot of that really messy trig stuff generally in the calculus that we do, but I like for us to review it. All right, last thing I want to talk about is the fact that you can take a derivative of a derivative, because a derivative is nothing more than a function. And so what the heck, why not take the derivative of it? So what would that tell us? If a derivative is rate of change of a function, the derivative of a derivative would be the rate of change of the rate of change. Okay, to maybe give that a little bit of meaning, if you're driving a car, your speed or velocity is rate of change of position. Then the rate of change of your speed is your acceleration. So that's a second derivative. We can keep going though. We can do third derivatives, fourth derivatives, fifth derivatives, etc. And it just depends on what we need and the meaning that it has in the context of the situation. All right. The notation that we use for second derivative is we use 2 prime marks, or notice where we put these are superscripted 2s right after the d and then right after the x, or y double prime. All right, so let's find the second derivative of f of x equals 4x squared. So we start by finding the first derivative, which I just bring down the 2 times the 4, it's 8x. Second derivative would just be the derivative of 8x, which is 8. I could keep going. I could do a third derivative. I know the question didn't ask for that. Third derivative, I would do 3 little primes, and that would be equal to the derivative of 8, which is 0. All right, let's do the second derivative of h of x equals 4 cosine x. So we start off by finding h prime of x. The derivative of 4 cosine of x is minus 4 sine of x. Remember, derivative of cosine is opposite of sine. Doing the second derivative, I do the derivative of sine, which is cosine, so it'd just be minus 4 cosine x. All right, next problem asks us to find the third derivative of 4 cosine of x. Notice the notation here. All right, 3, now I've got the 3 because I'm doing a third derivative. It's after the d and it's after the x there, or I put 3 little lines. Okay, so h triple prime of x is simply the derivative of the second derivative. All right, so I'm looking at this minus 4 cosine x right here, and I'm taking its derivative. That would be derivative of cosine is minus sine, so it would be end up being 4 sine x. All right, now we're going on to the fourth derivative. So it's getting like to be a lot of little hash marks. So now we're just going to put a little 4 in parentheses superscripted to mean the fourth derivative. And you can see how we do it with the dy dx notation. Again, superscript after the d, after the x. So the fourth derivative of 4 cosine x, derivative of, so here's the third derivative. So I'm taking the derivative of that, and the derivative of sine is just cosine. So it's just 4 cosine x. All right, find the 30th derivative. Well, we kind of jumped ahead there, didn't we? 30th derivative. Well, one thing I know is that it's going to be written h with a little 30 up there. Let's maybe write off to the side here. So h of x was minus 4 sine x. The second derivative was minus 4 cosine x. The third derivative is 4 sine x. The fourth derivative, oh, I did that wrong. Get rid of it. Okay. Fourth derivative was down here. It's 4 cosine x. All right, notice 4 cosine x. Oh, sorry, that's h prime. H of x was 4 cosine x. All right, putting it all together, hopefully it makes more sense. All right, so notice here at the fourth derivative, I'm at 4 cosine x. Well, that's where I started, was 4 cosine x. So this is going to be a cycle. It's just going to cycle through these values. 4 cosine, minus 4 sine, minus 4 cosine, 4 sine, 4 cosine again. So the cycle is 4 long. It repeats. So I could think about, okay, well, h of 5 of x is then going to be the same as h, the first derivative. So it'll be minus 4 sine x. So notice the fifth and the first derivatives are the same. The sixth derivative would be the same as the second derivative, minus 4 cosine x. The seventh derivative is going to be the same as the third derivative, which is 4 sine x. And then it all starts over. Okay. So the fourth derivative took me back to the original. The eighth derivative is going to take me back to the original as well. It'll be the 4 cosine x. Okay, so the first, maybe let's see, maybe this way. The first derivative, the fourth derivative, the eighth derivative are all 4 cosine x. So if I look at a multiple of 4 close to h sub 30, well, let's see, 28 is a multiple of 4. That would be equal to the 4 cosine x. And then the 29th derivative and the 30th derivative. So the derivative of 4 cosine x is the minus 4 sine x. And the derivative of that is minus 4 cosine x. So the answer here is minus 4 cosine x. Kind of cool how it's cyclical like that. All right, that wraps up lesson 2.4 and our derivatives of our trig functions. Thanks, guys. See you later.